Yes, children, welcome back to Chemistry Wala classes. This is Satish Kumar. In this video, I am going to talk about chemical reactions and the types of chemical reactions. First of all, definition. A chemical reaction is a process in which reactants can convert into products. Very simple definition. A chemical reaction is a process in which reactants can convert into products. So we can show with the help of simple process, that is reactants gives products. So this is the method to show a chemical reaction in a simple way. And you need to remember, when a chemical reaction happens, old chemical bonds are going to break and new chemical bonds will form. So how old chemical bonds will be broken and new chemical bonds will be formed, I am going to show you with examples. So then next step is types of chemical reactions. Generally you have 7 types of chemical reactions. 7 types of chemical reactions. In that, the first one is combination reaction. Combination reaction. So anotherly it is called synthesis reaction. Synthesis reaction. RXN, nothing but reaction. So what is the definition of combination reaction? Simple. Two or more than two reactants can combine and gives only one product. Either two reactants or more than two reactants combine and will get only one product. Then the reaction is called combination reaction. Nothing but we are making a compound by using two or more than two reactants. Example, very familiar. Since 6th class we have been learning C plus O2 CO2. So two reactants here left side and one product right side. Then second one is CaO plus H2O, calcium oxide plus water will get calcium hydroxide. So two reactants combine and we are getting only one product. And I told you in the definition, either two reactants or more than two reactants. So what is the best example? CaCO3 plus H2O plus CO2. So calcium carbonate reacting with water and as well as excess of carbon dioxide will get calcium bicarbonate. So two reactants or more than two reactants are combining and we are getting only one product. Here CaO is called calcium oxide or quicklime. Here CaCO3 is called limestone or calcium carbonate. We can call marble also, otherwise chalk. So this is the meaning of combination reaction. And I told you one point that combination reaction is one type of chemical reaction. So when a chemical reaction happens, old chemical bonds will be broken, new chemical bonds will be formed. How? Let us see one example. Here, this example, calcium oxide is there. In between the calcium and oxygen, chemical bonds are there. When it is going to react with water, the calcium and oxygen between chemical bonds will be broken. then you are going to get calcium hydroxide. So in the calcium hydroxide, in between the calcium, oxygen, hydrogen, new chemical bonds are forming. So you need to remember, in between the calcium and oxygen, in between the hydrogen and oxygen, the bonds are breaking and you are going to get new chemical bonds in between the calcium, oxygen, hydrogen. So this is the meaning of chemical reaction. Second type of chemical reaction you have decomposition reaction. Decomposition reaction, which is called desynthesis reaction. So what is the meaning of decomposition? In the name only the answer is present. Decomposition, nothing but breaking. So what is the definition? One reactant can split nothing but break. One reactant can split into two or more than two products. Then it is called decomposition reaction. Example, very simple example I am going to take. First one, CaCO3. I have taken calcium carbonate and I am heating. Then it is going to decompose calcium oxide plus carbon dioxide. So one reactant split into two products. It is the meaning of decomposition reaction. But it is happening by supplying of heat energy. I am supplying heat energy to the calcium carbonate. Then it is breaking into calcium oxide, carbon dioxide. So this reaction is called thermal decomposition reaction. In presence of heat, any reactant break into two products or more than two products, that is called thermal decomposition. Then second type of decomposition also we have, that is, I have taken water, the liquid, and I am passing electricity into the water. With the help of water heater, we can observe in the winter season. So when we pass electricity into the water can be broken into hydrogen gas and as well as oxygen gas. So here the water is involving in decomposition with the help of electricity. Then this type of reactions are called electrolytic decomposition reactions. Electrolytic decomposition reactions. And we have third type of decomposition reaction, that is, I am taking silver bromide solid which is in yellow color and I am exposing it to the sunlight. Sunlight here shown by h nu. H means Planck constant, nu means frequency. So silver bromide I am exposing to the sunlight which is in yellow color. So with the help of sunlight, silver bromide involves in decomposition into silver and bromine. Here bromine is gas and here the silver color is gray color. Yellow color silver bromide converted into gray color silver and bromine gas is releasing. It is happening, this reaction is happening with the help of sunlight. Then this type of reactions are called photochemical decomposition reactions. And here the bromine color is brownish color gas. Very very important, bromine is a non-metal, atomic number 35, mass number 80, and it is a halogen. Then third type of chemical reaction, very familiar, displacement reaction. Displacement reaction, another name is single decomposition reaction. Then what is the meaning of single decomposition? So here, after decomposition, third one is displacement. So the definition is very simple definition I am going to give you. More reactive element displaces least reactive element from its aqueous solution. More reactive element displaces least reactive element from its aqueous solution or compound, but that should be dissolved in water, is called displacement reaction. Especially metals involves in displacement reactions. But the displacement reaction majorly depend on metals reactivity series. Metals reactivity series nothing but we are going to arrange the metals in decreasing order of their reactivity. So the metals reactivity series we have like potassium, sodium, potassium more reactive than sodium, potassium greater than sodium, then calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, Cu copper, Ag silver, Au gold, platinum. So this is the metals reactivity series. It is common for up to intermediate. So in this reactivity series, potassium is more reactive, platinum is least reactive. So what is the meaning of more reactive? Nothing but potassium easily loses the electrons when you compare with all other metals in this series. So if any element is losing electron easily, that is called more reactive. If any metal is or any element is not losing electron, that is least reactive. So more reactive element displaces least reactive elements from its aqueous solutions. So I am going to give you one example, that is zinc is there. Zinc is solid, then it is reacting with copper sulfate aqueous solution. It is a salt but dissolved in the water, that is why I am calling copper sulfate is aqueous salt solution. Here copper is +2, sulfate is -2. So zinc is more reactive than copper. How I know how zinc is more reactive than copper? How I know means, here the reactivity series order is there. In this order, zinc is coming first than the copper. That is why zinc is more reactive than copper. It displaces copper from copper sulfate. Then you will get zinc sulfate aqueous solution and copper is going out. So this reaction is called displacement reaction or single decomposition reaction. Why I am calling single decomposition? Because only one reactant is involving in decomposition. CuSO4, that is a salt. After dissolving in the water, it is breaking into Cu +2, SO4 -2. That is why I am calling a displacement reaction is called single decomposition reaction. Next, one more example I am taking, that is iron solid copper sulfate. Here also same, copper +2, sulfate -2, iron is more reactive than copper. Then you are going to get iron sulfate aqueous solution, copper is going out. So here you need to remember copper sulfate color is blue. When iron displaces copper, will get iron sulfate or ferrous sulfate, which is in brown color. And next, many reactions we have, displacement reactions. And I want to tell you one more important point, that is, in some competitive exams they will give you like this: zinc solid plus CuSO4 solid. So here no reaction takes place. Actually zinc is more reactive than copper, but here the copper sulfate is solid state. Solid state means it is not having free ions. So if the salt solution is not having free ions, no reaction. So you need to remember. And next, so these are the very important displacement reactions. In your book they have given many. One more also there, that is generally will get magnesium plus 2 HCl. Magnesium is solid, for example, HCl is aqueous, then MgCl2 aqueous plus hydrogen gas is coming out. When metal react with acid, salt solution and hydrogen gas will form. But copper is there solid. If it react with HCl aqueous, there is no reaction. Why? Here the HCl is aqueous solution. Then why the reaction is not happening? Because copper is least reactive or less reactive than hydrogen. So hydrogen is more reactive than copper. So copper cannot displaces hydrogen. Least reactive element cannot displaces more reactive element. That is why copper is not displacing hydrogen from HCl. So no reaction takes place. So this is about displacement reaction. And next, double displacement reaction, fourth one. Double displacement reaction, which is called double decomposition reaction. So what is the meaning of it? Definition I am writing here: two reactants exchange their ions and form two new products. Here the reactant should be in aqueous medium. Two reactants exchange their ions mutually and form two new products. Then this reaction is called double displacement reaction. Example: Na2SO4, sodium sulfate aqueous solution. It is having sodium plus 1, sulfate minus 2. Then it is going to react with barium chloride aqueous salt solution. Barium is having plus 2, chlorine is having minus 1 from crisscross method. Then sodium sulfate will give sodium cation, barium chloride will give chloride anion. You are going to get sodium chloride aqueous solution, and from barium chloride Ba plus 2, from Na2SO4 SO4 minus 2. Then you are going to get BaSO4 solid, which is a precipitate. So any formula right side downward arrow is there, that is called precipitate. So barium sulfate is precipitate, which is in white color. So what is the meaning of precipitate? I told you many times, precipitate nothing but insoluble solid. And precipitate beside the byproduct is there, that is always called supernet. In the reaction precipitate is there means definitely you will get supernet. Supernet nothing but insoluble solid around, you will get a liquid, that liquid is called supernet. And a second equation also I am going to give you, that is AgNO3 silver nitrate, which is aqueous, and sodium chloride, which is aqueous. Silver is having +1, nitrate is having -1, sodium is having +1, chlorine is having -1. Then two reactants exchange their ions, and we are going to get AgCl, white color precipitate, silver chloride, precipitate shortcutly called PPT. Then NaNO3 aqueous. This is here supernet. So these two reactions are mainly called precipitation reactions, and as well as very important precipitation reaction we have, that is PbNO3 taken twice, which is called lead nitrate, Pb +2, nitrate -1. Then it is reacting with the potassium iodide, aqueous salt solution, potassium +1, iodine -1. Then we are going to get PbI2 precipitate, which is in yellow color, lead iodide. We used to call PbI2 is called lead iodide. Very important. And here the supernet is potassium nitrate. So these are the very important three precipitation reactions until you finish intermediate. And here I want to write one statement. The statement is, all precipitation reactions are double displacement reactions. But all double displacement reactions are not precipitation reactions. How it means? In all the double displacement reactions, precipitate cannot form. Then what is the example? This is the example. NaOH aqueous, Na +1, OH -1, sodium hydroxide, reacting with HCl aqueous, H +1, Cl -1. Then you will get NaCl aqueous plus H2O liquid. So here no precipitate is formed, but two reactants are exchanging their ions and forming two new products. Then it is called just a double displacement reaction, not precipitation reaction. And fifth one is very important, oxidation reaction. What is the meaning of oxidation? Oxidation is nothing but adding of oxygen to any element or compound. Otherwise, removing of hydrogens from any compound. Removing of hydrogens. So one best example is there, that is, I am taking copper solid and I am heating in presence of oxygen. Copper will turn into copper oxide. So balancing is important here. Copper oxide solid, which is in black color. So when you heat, when you burn the copper, you will get copper oxide, which is in black color. So here I added oxygen to the copper. Then adding of oxygen is called oxidation. And then sixth one, reduction. So reduction means removing of oxygens, removal of oxygens, or adding of hydrogens to any element is called reduction. Then what is the best example? I am taking here CuO, copper oxide solid, black color, and I am adding hydrogen to it, hydrogen gas for example. Then adding of hydrogen to the copper oxide is reduction. Then the copper oxide will convert into copper solid and water, which is in vapor state. Here actually copper oxide color is black, but after giving hydrogen to the copper oxide, it is converting into brown color copper. So very important. Reduction is nothing but adding of hydrogens or removal of oxygens. So this is about reduction, my dear students. And last but not least, seventh one, redox reaction. Redox reaction. So redox reaction is nothing but red, reduction, oxidation. So what is the meaning of it? In a single chemical reaction, simultaneously reduction and as well as oxidation takes place. So what is the example? Very simple. Fe2O3, which is called ferric oxide, reacting with either you take carbon or carbon monoxide. So here Fe2O3 converted into 2Fe and carbon converted into carbon monoxide. So here iron oxide or ferric oxide converted into iron, nothing but losing of oxygens, it is called reduction. Carbon is converting into carbon monoxide, it is called oxidation. So in a single equation we are observing reduction and oxidation, then it is called redox reaction. So in the redox reaction, Fe2O3 converted into Fe, then it is reduction. Carbons converted into carbon monoxide, oxidation. So the substance which is involved in reduction, that is ferric oxide or iron oxide, then it is called oxidizing agent. Oxidizing agent nothing but which is involving in reduction. Iron oxide is involved in reduction, so it is oxidizing agent. Carbon involved in oxidation, so the substance which involved in oxidation, that is called reducing agent. So carbon is reducing agent. So your oxidizing agent is called oxidant, another name. Reducing agent is called reductant. So these are the 7 types of chemical reactions, my children. I hope you got it. Thank you.